So we're continuing with the point of inflection and discussing the concavity of functions, but we're going to focus a little bit more on trig functions. So let's start with this one. We have f of x is equal to cosecant of pi divided by 2 minus x, and you know what? Let's limit our scope. Oops, that was weird. Let's limit our scope to just be from 0 to 4 pi. Okay. All right. So the first thing you want to take a look at is I don't like the way the cosecant of pi divided by 2 minus x looks, but there's an identity I can use, and it's a complementary identity. This is just secant of x. And let me tell you what I saw to help me pick up on that. It helps that I'm teaching trig, so I know to look out for it. But honestly, it was the pi divided by 2 minus x. That's like a complementary thing because, if you think about what the triangle looks like, I just saw the pi over 2 minus x, to be honest. So that I Googled it, and that's what I found, so I'm going to roll with that. So that means I have to find the first derivative of secant. And the first derivative of secant is secant tangent. Which, again, if you don't know that identity, that means if you don't know that by now, you would have to go about and derive it, which you can do, but it's a lot more work than just remembering it at this point. So from there, I need to find the second derivative. All right. So to find the second derivative, I need to use the product rule because those two are multiplying. So I'm going to take the derivative of the first function, which is secant tan, right? And I'm going to multiply it by the second function, which was tangent. Plus the first function multiplied by the derivative of the second. The derivative of tangent is secant squared. Okay? So now that I have that, I can say that I have secant of x times tangent squared of x plus secant cubed of x. So I know that drawing back from my identities, the Pythagorean identities, I know that secant squared and tangent squared go together to form a trig identity. So I'm going to do a little bit of factoring to kind of ease my way into it. So notice how much I'm relying on either remembering them or knowing that they exist in order to implement them. Like I said, the complementary one, I just Googled because I forgot. But this one I know for sure. It would be tangent squared of x plus secant squared of x. And here's the identity that I'm going to do a little substitution with. I know that tangent squared plus 1 would equal secant squared. So, do I want to replace the secant and work with a bunch of tangents? It's like 6 and 1/2 a dozen the other. Yeah, I'm going to do it. So I could write this all in terms of secant squared, but I'm going to pass. And here's what I'm going to get. So this would equal secant of x times tangent squared of x. Gosh, this mark is not going well today. Plus tangent squared of x plus 1, right? So I have secant of x times 2 tangent squared of x plus 1. Okay. So that's what my second derivative is, and that's what I'm going to work with. Okay. So here's the situation. I need to figure out when this will equal 0 or when this will be undefined. So essentially, I'm trying to figure out where secant of x would equal 0 or be undefined. Now I want to figure out where 2 tangent squared of x plus 1 would equal 0 or be undefined. All right. Well, secant of x never equals 0 because it's a reciprocal identity. So if I think about it as 1 over cosine, there we go. I'm trying to figure out where 1 over cosine of x would equal 0. Never happens because it's 1 divided by a number. Automatically doesn't work. But where it's undefined is where cosine of x would equal 0. And cosine is equal to 0 at, oh gosh, I remember this well. Yep. At pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2. Right, so all the odd multiples of pi over 2. And again, this is so fresh because I have it in my brain from my pre-calc class. I could go on and on forever. So essentially every odd multiple of pi over 2 would be a solution. However, in the original problem, they told me I'm looking at interval from 0 to 4 pi. So all of these fit in that solution. Okay? So if I look at the tangent function, okay. If I set that equal to 0, that means I would have tangent squared of x would have to equal, subtract a 1, then divide by 2 would have to equal negative half, which has no solutions because how can you square a number and end up with a negative? I don't even have to try to solve it. That's the amount of work I'm doing there because I'm thinking, big brain time, about what this actually means. And if I want to figure out when it's going to be undefined, okay. Well, if this is going to be undefined, it's got to come from the tangent squared, right? So tangent squared is actually sine squared of x over cosine squared of x. Oh, look, it's a cosine in the denominator. So as a result, I am left with these fine values to work with. These are going to be my point of inflection in the given range. I'm sorry, given interval. All right, because it's from 0 to 4 pi. So at this point, I just have to create my number line and test it out. You know what? I'm not even going to bother. It's fine. Right? I have 0 and I have 4 pi. And then we found 4 values. So 1, 2, 3, 4. Right? And this is where the rest just kind of works out the same. I just need to test out values here to see when the concavity changes. And I know for all of these, they're undefined. So I put the UD, almost decision day, May 1st. So I know that that's where I think it should change. Okay. So I need to look at my second derivative, which all this work. Okay, cool. It's right there in the black. Or in the red. Jeez, Rodriguez. So it's secant of x times 2 tangent squared of x plus 1. That's my second derivative. Okay. So since that's what I have, I'm going to pick numbers to work with. Between 0 and pi over 2, I'm just going to choose 0. So secant of 0 is a positive 1. Tangent of 0 is 0. Plus 1 would make it a positive 1. So this should be positive right here in this interval. I'm going to choose a different value. So now let's talk about pi. Secant of pi is a negative 1. Tangent of pi is still 0. Plus 1 gets me a 1, so that should give me a negative. Going back around. Oh, look. 2 pi is the same as 0. They're coterminal angles, so this should be positive. 3 pi is coterminal with pi, so that should be negative. And I think you know what I'm going to say for the last one. All right, so notice I use my trig identities to help me out with this. I figured out coterminal angles to figure this out as well. So that's all I did. So now I can say that from 0 to pi over 2, or from 3 pi over 2 to 5 pi over 2, or from 7 pi over 2 to 4 pi, f of x is concave up. So from pi over 2 to 3 pi over 2, or from 5 pi over 2 to 7 pi over 2, I can say that f of x is concave down. And that's it for this video. I'll show you another trig example so you can see me work my magic.